Alright, time for another DraftScience video presentation. Mostly going to be just a recital of why their physics is broken. Not that you need another model to compare it to that's much better, but even all by itself. Their arguments are really weak, the evidence is really weak, and people should have never jumped to conclusions, and that's essentially what they did. I mean, pretty decisively. They now think they have such a great model, and it's the great, most proven theory in the history of mankind, when it's all very circular, and it's all so abstract, and has built into it so many mechanisms to force the outcome to be what they want it to be. Blah 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 blah. So anyway, so I'll start with bent space. So I'll read this comment because it's sort of related to that, and then move on to kinetic energy, hopefully, in this video. Hopefully, I can get to all that. Anyway, so gravity is dependent on temperature. No, I said gravity causes temperature. Okay, or is your theory of temperature something else than kinetic energy of molecules? Well, I obviously don't believe there is kinetic energy, so you should just say energy of molecules, the motion of molecules. And yes, that's technically what we call temperature or heat. That's how we measure it, is how much do the atoms move. But the real truth is that atoms don't move unless electrons and protons move. And so I would say the more elemental thing is the movement of electrons and protons, and that's a little harder for us to measure with a thermometer. So we're not going to get that temperature because we need a device that can measure the absolute pressure of what, say, an electron is experiencing. So anyway, the simple theory is, just to reduce it, so the alternative to whatever a bent space would be, I have no idea, whatever the mechanism would be, that completely defines, I mean, it shows you why there's an inverse square law. It provides a complete explanation of gravity. So let's say the universe was just force, bent space, whatever, and electrons. And let's say the electrons couldn't move, okay, so they were stuck here. Then you could argue by a theory of action-reaction, a theory where the force, okay, is pushing the objects, and let's say they can't be pushed, so all you can do is reflect. The difference between an absorption and a reflection is a simple argument, is that if it doesn't move, okay, because there's another force that hits at the same time, let's say, you can understand that both forces would just reflect. And you can see that with pool balls and different things will tell you that's what's going to happen. The trick is when the force actually hits, and let's say there's not an opposing force. Let's say the opposing force is way over here, so it doesn't hit it for a little while. Well, then this piece of force is going to push the electron, let's say it was, until this piece hits it, and then they'll both reflect. So the reflection doesn't happen immediately. So the difference between an absorption and a reflection is just time. Eventually everything reflects. It just takes longer for some things to reflect than other things. And while it takes longer, the truth is this will not be going, this will not equal the speed of light. This is the speed of light. This is the speed of light. But this won't be. Okay, the transition from here to here will be at less than the speed of light as it's pushing the electron to a new location. And again, once this force hits, then another force can hit it, move it back. So the electrons and protons are in a constant energy field. So again, if they couldn't move, you'd say, okay, well, every piece of energy just automatically reflects. So everything's just reflecting automatically. Whatever goes in comes right out. And you'd end up with pretty much no event. There'd be no such thing as a gravity being created anyway. And the whole point is if the stuff is moving, though, if you are moving it, little segments, this moves to here, and then this moves to here, and this moves to here, and it moves to here, because it's getting constantly bombarded by the universe at a different rate. at any 1 millitrillisecond of time, there's a little bit more stuff hitting from this side than this side. And that means this blob will move a little bit more, in this direction. And then the trillisecond later, a little more energy is hitting from this direction. So it's moving this way. And as it's moving back and forth, okay, from here to there, as it's jiggling, as it's browning, motioning, what is it doing? Well, it's absorbing a little bit of energy every time it moves, because you do this less than the speed of light thing. The force moves less than the speed of light, so the reflection is delayed. And let's understand, things stop because they hit an opposing force. So just to understand it, it stops because it hits an opposing force, and that causes a reflection, which is essentially this just doing this, and this just doing that. So the reflection is really in the form of you going in the same direction, in the sense that you will reflect something going the opposite direction, which is the same as you going in that direction, and vice versa. You'll head in the direction of the opposing force. But anyway, so the point is that obviously the imbalance will be in the fact that this event, this reflection, won't happen immediately. And because it doesn't happen immediately means you've taken some energy out of the universe, because this would have been here, and instead this is only here. The universe is cooler, okay? If these objects move, it means the universe gets colder, because this stuff moving has taken some of the heat out of the universe. Some of the motion in the universe is delayed, which is the same as extracting it from the universe. So yes, the elemental heat is what we're the consequence of gravity. The cause of gravity is absorbing heat out of the universe. This is the only way I know how to say it. The heat is in the universe in the sense that all this stuff would be ending up in places very different when this stuff moves and when this stuff doesn't move. So if it doesn't move, hot universe. If it moves, cold universe. It's that simple. But that's gravity. The simple answer. Not the crazy, convoluted, mushy, nonsense answer. Okay, so let's go to why we have this bad theory. So nobody had a good explanation from Newton's time. Newton just said this is what it does. So obviously what I'm pointing out is that obviously this motion of electrons is in all directions, which means essentially that's the inverse square law. That's creating a spherical symmetry, which ends up creating the same lack of energy in all directions. The lack of reflection is in all directions, and it will decrease by the inverse square law because it's a bunch of vectors. It's a bunch of little force bits. So it explains the inverse square law. Anyway, from Newton's time, they really didn't have anything. So from Newton to the early 1900s, no good theory of exactly how gravity, this apparent what's called an attraction, and again, it's only because of how they looked at it. They could have chosen to try to look at it two different ways. You say, are we being pushed or are we being pulled? And they seem to have some sense that we were being pulled, even though the only part of gravity we feel is the Earth pushing back. And so that should be sort of a giveaway that maybe the thing that's missing is the push from the other side to balance us, and that somehow the material object was somehow absorbing something that wasn't able to allow us not to be pushed into the Earth because there wasn't any counter push. So anyway, so that didn't occur to anybody. Well, anyway, so Einstein shows up and he does this simple kind of two-dimensional analogy of saying, well, this tablecloth idea, you put a weight in the tablecloth and it sinks, and You could force things to orbit, and so it sort of fits with some kind of the way you would create a solar system is by, that'll work. Now, it's a simple mechanism. This isn't any much different than the idea of, seeing a pattern in water waves and then saying, well, because water is mass, physical mass, interfering with each other, physical masses, that somehow light is doing the same thing because it comes up with a similar type pattern. Same kind of mistake, I would argue, is to take a two-dimensional mechanism that doesn't in any way visually expand into 3 dimensions. You can't use the bent fabric idea in 3 dimensions, so it's not going to do much for in terms of provide an explanation. And of course, the reason it's doing it is a material reason. It's a water wave reason why that works in terms of creating a whirlpool or creating a mechanism that creates orbits. They're not even the right orbits, by the way, but whatever. In many ways it fails because it has friction in it, lots of things. Well, anyway, so this vision that you could take this 2D model and expand it to 3 dimensions mathematically and create some sort of synthetic idea of a reason why things move in. But it's not a very good reason. It's not like I said, it's not elemental. It doesn't abstract into 3 dimensions. So, but anyway, so Einstein's challenge was to come up with some theory, some mathematics, something more rigid to give it some sort of meaning, So his challenge is to apply it to the fact that Mercury has a uneven precession, that it, is wobbling in its orbit, so it's spiraling. That's probably the best way to say it. So instead of just being in an orbit that just stays here, it keeps cycling the orbit. The lopsidedness, the ellipse, keeps moving with each cycle. And the other planets, generally speaking, don't do that as much, and blah, 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 blah. And so it makes, it's a little inconsistent with just using Newtonian physics. Now, the key to that is that, nobody bothered trying to figure out exactly how much the sun moves in space. Because the sun is enormous, but it's very light. There's only 80 times more gravity on the surface of the sun. It's not, I said 8 times? Well, even if it was 8 times, even if it was 80 times, it might just be 8 times. It's not all that impressive. It's 80, I think it's 80 meters per second. So it's not that much more than Earth when you think about it. I mean, considering it's 1,000,000 times bigger, it's so much less dense because it's just made out of light hydrogen and helium. Anyway, so the idea would be is this giant sun, its actual gravity, its actual center of mass, it's a swirly ball of liquid and crap, can move. You could argue that inside what we see as the sun can be a moving center of mass. The density of the sun can be wobbling quite a bit, and we wouldn't see the sun actually moving because we're seeing something so much further from the real density of the sun, the real core of the sun where all the real mass is. And so that could jiggle around and we wouldn't be able to see it. And so we wouldn't put it in our calculations that the sun moved, because we didn't see it move. But the fact is it could be moving. And that's why Mercury is wobbling, is because Mercury's really close, so we can sense the wobble. The further away you go from the wobble, the harder it is going to be to see it because your distance gets bigger and bigger and bigger. And so any little tiny fluctuations in the gravity aren't going to be noticeable from a great distance. They're going to be neutralized by the distance. So Einstein basically came up with math that does the same thing as that. He came up with a mathematical equation that almost nobody can solve, that has a bunch of equations built into it and a bunch of stuff, that basically creates a circumstance where only Mercury is affected by the effect because of its proximity, and nothing else is affected. So it fixes Mercury without breaking Earth or Saturn or any of the other planets. And you can understand, if you do a little thinking, that yeah, that's quite possible to do, because there's a huge difference between the proximity of Mercury as a percentage of the other planets. It is a lot closer than everything else. Anyway, so part of Einstein's math to do that, he originally, in his original papers in 1905, still thought gravity would bend light the same amount as it bends an electron or it bends any other piece of matter. But in doing those calculations for the challenge of describing Mercury, he changed it to 2x. And so then in 1919, Eddington took that new number and said, well, with that new number, that means twice as much bending, I might be able to see it. Okay, so if there was an eclipse, I should be able to see light bent from objects behind the sun, or not behind it, in the environment of the sun. And I'll be able to see that 2x bending, because that's a lot of bending. I mean, it's twice as much. It's a difficult experiment, but it's doable. That was the opinion. Now, the fact is that it probably wasn't that doable, and Eddington had terrible bad luck. He sent 2 different people, went out to different places, Africa and South America, to go see this eclipse. It was in the equator latitude, and both of them had terrible weather and got very crappy results. Eddington, in his own journal, describes them as something like 10% of what he was looking for, which that's really bad. 10%. So he was hoping for 10,000 stars in his images. He got 1,000 stars in his images. So a pretty substantial degrade. It's a little too wet. All right, well, I'll take a little pause because that'll have to dry. Anyway, so I'll draw a little bit of this and such. So I'll be back. I ought to fix the keyboard. Yeah, I could do the shortcut. Yeah, it should be close enough. Anyway, so the idea is the sun is here and the earth is here, and we're going to view a star. Now, the people have this perception that the star was behind the sun, and that Eddington saw stars that were behind the sun. That didn't happen, because Eddington was fairly intelligent and all that kind of crap, and he knew that the sun has a field of radiation around it that's rather substantial. Okay, that the sun creates an atmosphere. Now, no one thinks of it as an atmosphere, but that's what it is. It's a bunch of little sun particles, actually, ionized gases, all kinds of plasma, all kinds of stuff. So the sun isn't really this size. The sun, okay, to get to the actual part where there isn't any of this atmospheric crap, you have to go out pretty far, okay, at least a radius. And so this is the actual sun size. And the idea is, if you don't want to view something through that, because Eddington was, like I said, a pretty smart guy, he probably knew that that's just going to cause the light to scatter in all kinds of directions, and you'll see it everywhere. You'll see it over here, and you'll see it over here, and you'll see it here, and you'll see it here. Because it's going to go everywhere. Okay. Now, that's part of the problem. And, it's something to understand why physics, when it says, when the conventional physicists say, well, we've confirmed it in many ways, all the other ways they confirmed it are tainted by a lack of understanding of that principle. Sorry about that insane amount of glare. I'll get rid of that. All right, so the idea is to look at something that's outside of that, which means something that you can have a line of sight that doesn't go through that mixture of gases and ionized particles and crap. And the idea is you're supposed to see a 2x, you're supposed to see the star here where it actually is, and instead, because the light is bent by the gravity, I don't know exactly how to draw that in this circumstance. I guess I'll put it, because it's bent by, it's supposed to be here, and because of the bend in the gravity or whatever, you'll see it over here. So it's a bad drawing, but there. You'll see it here, but it's actually here. Okay, so that's what Eddington is looking for. And so the whole thing happens with time lapse. You got to take slow pictures, you know, and what you end up with is a slide that has a bunch of blurs on it, okay, where the little stars in the background are just swashes, you know, blurs in a direction. So all the stars are these blurry things in a direction. And what you have to do is calculate where the actual position is. You have to calculate an actual position and then figure out whether your actual position matches, you know, what place it's supposed to be in. Anyway, not a simple thing to do. Tiny little bit of difference between where it's supposed to be and where it actually is. Like if they could overlap them, there'd be, you know, little tiny bits of difference. So you're measuring very small amounts of difference in what were very bad pictures. You know, 10%, again, 10% of the quality he expected. Anyway, so he decided to not say what he said in his own journal, which is, I wouldn't stake my life on these results because it was so bad. His journal describes a failure in the making. He's basically describing how this is terrible, like everything's going wrong, the stuff is damaged, all this couldn't be worse, really. And but that's not in the New York Times headline, which says Einstein proven right. So the idea was he found this 2x. So he not only proved that light was bent by gravity, you know, 1x amount, he found the 2x amount. Okay. Now I would argue he didn't even find the 1x amount, because I would argue it didn't happen. I mean, it is garbage as evidence. It's just not good enough. The experiment is of such a poor quality and that it's just not good enough. And the fact is, it's never been repeated. Now, it's never repeated to this 2x amount. Now, you might be able to argue that some of the other experiments that were done might have verified at least the 1x amount. But the truth is all of those experiments are tainted also. Either because they're so underperformed, that is, the equipment is worse than the equipment used in 1919, less capable equipment, or the circumstances are also bad. I mean, they had bad weather, a bad eclipse. The eclipse is way too low on the horizon. See, the further your eclipse is down, so you want a perfect straight up eclipse, so you go through the least amount of atmosphere. The more atmosphere you have to go through to view it, the worse your photographs are going to be. The more distorted they're going to be by the atmosphere, which makes the whole experiment useless. So the other eclipses weren't very good. You know, there were eclipses here, you know, at 4 o'clock in the afternoon kind of thing, or at 10 in the morning kind of thing, not straight up ones. And the only one they did when it was North America had the greatest, you know, 12 noon eclipse. You couldn't get better, perfect weather, and only an amateur did the experiment with a, you know, 4-inch telescope. You know, not the same equipment at all. Anyway, so not a very, so this really hasn't been confirmed in any way. And the only other experiments that they have are experiments where they aren't outside that murky spot on the sun. So instead of doing, you know, well, I'll draw it, redraw it. So there is, you know, the guy whose name I can't remember, you know, who recently died, tragically, or sadly, or unfortunately, I'll just say. You know, he, NASA engineer, spent years doing laser experiments in the, you know, shooting lasers through space and all that kind of crap. States that there's no records of NASA ever seeing, okay, any light bending outside the LAM, okay, the 1 radius distance, okay, from the surface of the sun. So he's basically confirming that NASA does see, you know, it can see, it receives radio signals from, say, an object that is actually behind the sun. And it receives those radio signals because somehow the light gets to the Earth. When it gets there, though, because it goes through this murky stuff, and like I said, logically you can know that even if I was over here on the Earth, I could get the signal. I could get the signal here if I was on the Earth, because the signal is going to go everywhere because it's being scattered as it goes through here, and the image will essentially be everywhere. You'll be able to see it anywhere you go. You'll see it, some trace of it, because it's going to scatter in every direction. So, person who knows about scatter knows that it'll take the shortest path and it'll take the most preposterous longest path. It'll take both paths. And you'll be able to receive it at any location. So if you're going to just assume we'll just wait till we're at this shortest path location, and then we'll make the argument, that it confirms the light was bent, by gravity. No, it was just scattered by dirt. And so there's a huge difference. You can't tell the difference just looking at the signal you're receiving. You can't tell from the signal. The signal's not going to tell you, I was bent by gravity, or I was bent by scatter. It won't be able to show you the difference of what caused it to arrive at your location. So all the other experiments depend on some form of radiation going through the corona of the sun, which, in my opinion, makes them kind of useless as gravity arguments. Because you could argue it's gravity, you can say it, but you can't prove it just wasn't scatter. And so, it doesn't mean much. So anyway, Einstein got New York Times headline, Einstein proven right. So Einstein really wasn't a household name. Einstein wasn't the man in physics. He was an interesting character. Yes, physicists paid some attention to him because he did, make arguments. And some of his other papers were good physics, interesting physics anyway. So, but this removes some element of doubt, okay, because something extraordinary was established as a fact. Now, the fact is the Eddington experiment hasn't been redone with, equal technology, and the real telling point is that from space, you can do this experiment without an eclipse. So you can do it anytime you want. And it takes 10 minutes. Literally, 10 minutes. And there's 400 times better resolution. So that means that, like Eddington, if you were to make a comparison, 10,000 stars, and you only got 1,000, you multiply that by 400. Okay, 400 times 10,000. The quality of the images is 400 times better from space. You remove all of the atmospheric garbage and you can see 400 times more clearly, which means you can see objects much, much smaller. That's why the Hubble telescope was such a great innovation. So it's a huge advantage. I mean, you're talking 12 millimeters versus 12 feet of telescope. I mean, it's a huge advantage. You're talking about a big giant lens. Now you just need a little tiny lens. And that would be, say, 200 times. So you could use a tiny lens and you still have a 200 times advantage. Huge, gigantic. And obviously we've been in space quite a long time. It would take just a regular camera could do the experiment at the Eddington resolution. So you could take a really cheap old 1970s Kodak camera and you'd still have better resolution than Eddington if you did it from the space shuttle. That's how big an advantage doing it from space is. And we're supposed to believe it's never been done. Never been attempted. Come on. Anyway, really bad piece of evidence. So we really don't have any evidence that gravity bends light. And we certainly don't have evidence that it bends it twice as much as every other material object in the universe. It's something moving the speed of light, something going as fast as anything go that we know of in the universe is somehow bent more, than the stuff moving really slow, by some magic. Something that seems pretty no force interacts with any force. So the argument would be, is all this stuff moving the speed of light, whether it's magnetism or electric field or whatever you want to think about, all these other fields of all these other elements, none of these fields interact with each other. They have to go to a material object before an event can happen. And yet we have this case, this one single case, based on this one single experiment, where we're going to make the argument, nope, there's an exception to the rule that always applies. So a rule that always applies, every magnetic or electric or any other kind of experiment, the field can never interact with the field. It has to get to a material object before an action can take place. That rule exists for everything except photons and gravity. Somehow photons are bent by gravity. Photons aren't bent by magnetism, even though they're supposed to be electromagnetic. They're not bent by electricity. They're not bent by anything else, just gravity, and they're bent twice as much. It's a very bold and extraordinary claim. It got New York Times headlines that Einstein proved his theory is correct, and yet the evidence is just not there. It's not nearly good enough. All right. Time dilation. So time dilation was now a second argument. Okay, so Einstein proposed that there would be, that time slows down as you move faster and faster. And the real argument is, I mean, a lot of these conversations took place before Einstein's paper. The Time Machine was a novel written before Einstein wrote his paper. It's an old story, not a modern story. Even though it has a lot of modern elements and seems like something that had to be written afterwards, it was written before. And so this notion that you could escape the dimensions, you could escape time by moving faster than the clocks you're measuring the time by, would somehow be possible, time travel. So this was something speculated about, but it's in some respects just an irrational because all of this time travel creates these paradoxes where yes, you go back in time and kill yourself, and then how could you go back in time to kill yourself if you killed yourself? It doesn't work. You can't change the past, because if you change the past, you change the future, blah 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 blah. Cause and effect, it breaks all of this stuff, and so it's appealing to some people for whatever reason. They like to daydream about nonsense, but so the elemental argument was corrupt in a sense right from the start, because time is rigid and there's no evidence that you can bend it or change it. And what you're really talking about when Einstein's talking about clocks moving slower is he's talking about a kind of cryogenics, a kind of, I can freeze your process. That is, I can make everything you're doing happen slower, and therefore the rest of the universe going at the regular speed passes you. In a sense, it's going much faster. But there's no mechanism to blend these two time frames. There's no mechanism that would allow you to be in one part of the universe, okay, where the energy from the other part, it's moving faster, so we just draw faster is smaller. This stuff's jiggling around faster, and all of a sudden you're going to be in some frame, okay, where you only jiggle slow, because the jiggle from here is going to get into your universe. You can't eliminate the two universes from mixing. The photons flying through this space are going to fly through your space at the same speed. So again, all you could really do is imagine cryogenics. That's the only real physics you could do here. Is just, I could put you in a refrigerator, okay, and then I can isolate you from the real universe, and I can freeze you, okay, and then I can wake you up in the future. But you weren't alive. You didn't live 10,000 years in the real world, okay? You just went to sleep. And that's what you can do to a clock, is you can put it to sleep. But you can't do any of this dilating of time or changing the actual how time functions in the universe. There's no evidence that you can do any of that stuff. All right, so the key pieces of evidence are GPS, and there's probably some other kind of nonsense. But somehow they say, okay, this proves it because the clocks are running at different rates. And Einstein's theory has two elements, unfortunately. It's relativity theory, special and general. And the two theories, one of them has to do with speed, how fast you're moving screws up your clock. And the other one has to do, in a sense, with gravity. Now, I would argue that the gravitational argument really is, the same as the speed argument. And the simple argument is that if you're on the surface of the Earth versus being on a satellite over here, you're in more gravity. You're in a lot heavier gravity. You can feel the pushing. Because you can feel the Earth pushing you up means, you're not feeling yourself pushing down, but you're feeling the Earth pushing you back up. Well, the truth is you are being pushed up and down constantly on the Earth. All right, there's elements of you that are going down, and there's more elements going up, and they're equal, and that's why you're staying in one position. The number going up is the same as the number going down. You don't feel the ones going down, but you're definitely feeling some of the ones going up on the bottom of your feet or the bottom of your ass or whatever. So you're essentially jiggling in the space. You're vibrating on the surface of the Earth. And you do the same from out here, but you would do it at a much slower rate because the gravity is much weaker. So you can sort of understand that if I was to take this path, this entire path is a very long path, this little jiggle, it might add up to 10,000 miles, And this would only be 1,000 miles. So the two things will travel the same distance, but, in terms of spatial distance, absolute space, point A and point B, they'll get to them at the same point, but one of them got there doing this, and one of them got there doing this. And the one of them doing this traveled 10,000 miles in the same amount of time that this one traveled 1,000 miles. So obviously this one had to have a higher velocity. So we're really back to the original Einstein theory of speed breaking clocks. So the clocks on Earth are broken. They're the ones that actually are the ones that are time dilated. So that's a part of the thing. People think the satellite moving 22,000 miles an hour is where the clock breaking problem is. No, it's really the clocks on Earth that have been dilated. They're telling the wrong time because they're the ones that are being moving faster. They're the isotopes, that aren't reacting. Not producing radiation at the correct rate. Now, the simple argument is, so it's just really, the argument is that this all can be explained by just saying you're breaking a clock. So the thing we use to measure time is the decay of atoms. Now, the decay of atoms, the clock, is very reliable in the same environment. If I have two clocks here and a clock here, atomic clock, they'll be very reliable because they're in the same environment. But if I change the environment they're in, all of a sudden this isotope isn't so reliable. So if I take a radioactive element, so let's just draw this as radioactive, and I don't put them in the same environment, I change how they tell time. So all I have to do is put more of this stuff. So I could say that a uranium atom has a half-life of 10,000 years or something. The fact is, though, if I put it with a bunch of other uranium atoms, that is, I put a bunch of them together, all of a sudden I'm down to 2,000 years. They're decaying quicker. So they decay quicker depending on how many of them are in the environment. So I can change the clock. I can break the clock quite easily by just changing how dense I've made the material, how much other atoms I put in between these atoms. And so I can just change the isotope a little, the mixture, and I can change how fast it tells time. And so logically you could understand there could be other mechanisms that decide when something decays. And I would say that what we know from this simple fact is that the decay rate is a cause and effect. There's something causing things to decay. It's not random. They don't randomly decay because of some little random thing inside. They have a little fairy inside that says, I'm going to decay now. their decay is completely environmentally manipulatable, which means it's a cause and effect. There's some kind of event that has to take place. And so I could just make the event almost anything, so I'll just make it for example. The event could be that a piece of energy has to go into it at exactly the same time, and the two pieces of energy have to hit the center at exactly the same time. Now I could argue that now if I give that velocity, what's going to happen is there's going to be more energy coming in this way and less energy coming in this way. And now I'm going to change how often this event could possibly happen because I have fewer permutations. Because there's less energy coming in this side, I can't get heads. You know, I can't do the miracle event as often. I don't have as many permutations because I'm causing less things to go in this side and more things to go in this side. Having more in this side doesn't do me any good unless I have more coming in this side. So the fact that I have less coming in this side means there's less likelihood of the event because I'm flipping the coins less often. If I flip the coins less often, I have less possibility of doing the whatever, having it land on its edge. And that's just a fact. So something this simple explains why decay is affected by motion. And the simple argument is there's more motion on the Earth's surface than there is in space, and therefore you're going to have a difference in your radioactive isotope. Your isotope will decay at a different rate on the Earth than it will in space because the environment is different. That's simple. All right, third thing would be, I already did it, was the precession of Mercury. So the precession of Mercury was connected to the 2x bending of light. The 2x bending of light was confirmed by a very skeptical, I mean, there's even physicists who admit that Eddington might have even cheated a little by only using the slides that confirmed the theory and threw out the slides that weren't saying that it was true. And so it might even be that corrupt. So it's not even that it's a very difficult experiment done with really crappy experimental results, but that it might have just been cheated also. So never repeated with better technology, never repeated from space with 400 times better resolution. So not really a credible piece of evidence in hindsight. You can just wipe it out as, why are we even paying attention to it? It should just be ignored as a piece of evidence. It's so bad in the clear vision of hindsight. And again, the clock breaking theory versus the eye warped time. There's no warping of time. You can just break clocks, and that's it. If I give you velocity, I'm going to change your material structure. The idea is what is velocity? Velocity is your atoms moving. If your atoms are moving, then your electrons and protons have to be moving. Something has to be pushing them. You get into all these arguments, but I would just give you the simple illustration would be if we have this notion that it's like a school of fish, your material substance, okay? And what you're really doing by moving is having more little bits of you moving in the same direction. All right, so they're moving in all kinds of directions, but I'm going to change it so more of your electrons go this way than go that way. So if 50 are going this way, I'm going to have 49 going that way. And that little bit of change means you're going to end up moving in space over time in that direction. But what if I start really changing that number, and we get it to very extremes? And so now you're going really, really fast because I have 99 going that way and only 1 going that way. Now you're almost going the speed of light. Well, what happens when you actually go the speed of light? Well, yes, then every single bit of you is moving in this direction. And essentially you're just becoming a force because you can't push matter at that speed. So you're just sort of saying that you're just converting something into force, when you push it at that speed. But that's all you're doing is you're converting it. So you're not going to be your physical shape anymore when I give you a high velocity. If I give you a high velocity, you're going to become invisible to the world behind you and really visible to the world ahead of you. you're completely changing your physical structure. You're not going to reflect light the same way from stuff coming in from the sides. None of that's going to be even possible anymore because you're moving so fast. So let's say a photon was a composite object and it took a little bit of time for it to interact with a surface. If you move the surface really fast, there's no way the photon could interact. So even if I did the spaceship analogy of having a light clock inside of a spaceship, one of the biggest problems of this idea of shooting light back and forth between the spaceship moving this way is that, well, if light does take time to hit a surface, dot, 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 it has to take a couple of events have to take place. Well, I'm moving fast enough where the dots would happen on really distant parts of me. So if the light had to hit right here, dot, 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 and I'm moving really fast, well, then the dots are going to hit dot, and then there's going to be a dot here and a dot at my feet. The light won't be hitting the small enough surface to be recorded as light anymore. So you couldn't even reflect it because it wouldn't even be in any coherent form to be reflected. So anyway, lots of thought experiments, lots of ways to understand how it's just not good theory. There's not really any real physical evidence. There's no show me experiment. There's no this explains this. This makes it so clear that time is warped and time is bent and space is doing all this wacky crap. And yes, the regular conventional physicists haven't come up with, they don't play much with mechanical theories as competing theories. And, I don't think it's that hard to do, obviously, because I did it. So yes, you can understand that you can make a mechanical theory of the universe that explains why cause and effect does work, and you can come up with rational causes for effects. But you need experiments. Experiments are the real, what you're really trying to explain. That's the evidence in the court case. And the simple argument is there's not nearly enough evidence to prove anything called bent space or to prove a fourth dimension of time or any of that stuff. Way too thin. Alright, so kinetic energy. Unfortunately, let's see what time it is. 47, yeah, we're getting there. Alright, I'll just do a little of it, and then I'll save some more of it for another time, I suppose. But, I'll take a little pause, and we'll move on. Well, decided I might as well not mix the subjects because, we're already 47 minutes. Alright, I just was in the mood, so I'll just make a separate video, either subsequently or tomorrow or whatever. Because the paradoxes are just they're so all over the place, and the fact that the very fact that no intelligent beings, people who know something about physics, are not compelled by those kinds of things. Paradoxes should be incredibly interesting to smart people. They should be wanting resolution. Oh, I must understand why. I must have an explanation. And it just amazes me that I can point out these paradoxes and there's no will to explain them away at all. There's no will to say, gee, that is really weird. We got to figure that out. There must be an explanation. Let's find it. Nothing like that. Just a complete, we don't want to pay any attention because we don't want to have to know that our theory has elements in it that just don't make any sense, that aren't rationally coherent. The two arguments don't fit together. Kind of like the idea of no force interacting with a force, and yet gravity bending light twice as much as every other material object in the universe. It doesn't make any sense. And yet they don't want to even try to explain why it would be. Why would something that wacky be the truth? It doesn't, their brains don't say, I have to find a solution to that because I'm riding on this train, and it's got square wheels on it, and I got to know how does that work? That can't make any sense. Or they're like Toys R Us is written on the wheels, and they're made out of plastic, and you're like, what? I mean, a train that's got Toys R Us wheels on it? Come on, that can't be right. you'd say they'd have to have an answer, and it's just the fact that people don't have to have this answer is the explanation why this physics is so bad. Is because people are their brains don't work because they're not doing what is the sensible thing to do, is to say, let's get a better answer than that, because that answer isn't good enough. And the fact that they're not saying that surprises me. I didn't think people were this stupid. I mean, we did land on the moon, and you're saying, shit, that was quite an accomplishment. How could people this, dim and accepting of paradoxes, how could those kind of people land us on the moon? That doesn't seem like doesn't make any sense, frankly. But anyway, we'll see how it goes. Quite strange. So that's part of my, that's part of the detective work I have to do, is to figure out what is it, that is creating this unanticipated dishonesty, among people who are supposed to be intelligent and way above believing fairy stories. Why are they suspending reason and logic, denying that their evidence sucks, which is just something they should be perfectly willing to state, is that, oh yeah, I wish we had better evidence because this evidence really stinks. And they won't do it. What happened to their integrity? How did they get to, you're not supposed to be able to march up the staircases of knowledge, having such a backward understanding. Something, it's like you can't get to fourth level three-dimensional chess and not know how to tie your shoes. I mean, those two things, there'd just be no way you could say, oh yeah, he's great at four-dimensional chess, but he doesn't know how to tie his shoes. There's just no way that this makes any sense, that intelligent people can get to some point where they can do these other logical abstractions, where they can find the criticisms with the Jesus theory, for example, why it seems a little preposterous to devote your life to a 2,000-year-old fable, yet they can't see that that's all they're doing, is devoting their life to fables, stories that aren't well evidenced, and they're just stories. You can make up lots of bullshit as answers, and there's lots of pseudoscientists doing that, lots of flat earther types doing that, but they're all just in the same category. So they'll critique the fakers and the phonies, but they're just as fake and as phony because they'll use whatever shenanigans to keep defending a theory that they should at least admit is way under evidenced. Nobody can be thrown in jail based on this evidence. Nobody could even be fined 25 cents based on this evidence. It's so bad. They're just participating in a mistrial. It's a kangaroo court. It's bad. It's really poorly performed trial of the truth. Anyway, all right, now it's definitely enough of a video. Okay, so till the next time, and such and so forth and whatnot. This has been a DraftScience video presentation. Yeah, that's what it's been. Pretty much. The entire thing seems to have been a video presenting an argument and such. Yeah, the evidence seems kind of conclusive. We'll go with that.